I think, okay, I was going to say, I think that they just sort of say, when they're talking about using a calculator for this section, they're just like, use it if you want to. So we've got the velocity of the wind in a hurricane during a hurricane is given by this function v of t is 5t minus t squared plus 100. And we want to know what the average velocity of the wind is. So anytime you're just given a continuous function, the average of that continuous function, so we want the average velocity on 0 to 4, right? 0 to 4. Yeah. All you have to do is do the mean value theorem for integrals, 1 over b minus a times the integral from a to b of the velocity function of that function. And all their answers are nice numbers for the most part. So we'll just do the integration and see what we get. An integral of 5t ought to be 5 halves t squared, then minus t cubed over 3, and plus 100t. And we got to do that from 0 to 4. And the 0 is just going to end up being 0. And I just want to caution you about when the lower limit is 0, just make sure that all those things are 0. Take a look at it and make sure. Don't just assume that they're all 0, because if you have like e to the x and that's a 0, that's not 0, that's 1, right? Or cosine of x, that's not 0 when x is 0, that's 1. So just be careful with that. But if it's a polynomial, it's gonna be 0. All right, so anyway, plug in your 4. So we got 1, 4. We got 4 squared is 16 over 2 is 8 times the 5 is 40. And then we got 64 thirds and plus 400, and then minus that 0, like we said. And I don't know, what does that come out to be? That's 10 plus 100, and then minus 64 twelfths. What is that? 32 eighths. That's 16. No, it's not. What did I say? 64 twelfths? Yeah, 32 sixths. This should be 16 thirds. So minus 16 thirds, whatever that is. 330 minus 16 is 314 thirds. Looks like that's choice D, 104 and 2/3. I don't know why they would ever write something as a mixed number, because this isn't 3rd grade anymore, but that's fine. I mean, if you write things as a mixed number, that's okay. But don't do that, because nobody does that after 3rd grade. Maybe 4th grade. My kid's in 7th grade if he still tries to do it, and I yell at him. I'm like, nobody does that. Don't do that. Teacher lesson. Cool. Good with that one, Ryan? Yeah. Other questions? No, I mean, they're going to want you to evaluate that to something. If it's not a reduced fraction, that's fine. But like if you just, if you wrote, I don't know, I mean, I guess that was already a reduced fraction. But like if you left it as, for some reason, in terms of sixths or something like that, that's fine. But they don't want you to leave it like that. $31. I don't know, we'll find out. Let's see. I hope so. All right, we got a velocity. Okay, now it's traveling at speed of v and gets 4 plus 0.01 v miles per gallon. Its speed, so we're just calling that v, is 80 times t plus 1 over t plus 2. And we want the amount of gas in gallons in the first 2 hours. All right, so let's see. Miles per gallon. This should be, so our velocity, what did they say? I assume it's in miles per hour. Yeah, miles per hour. So what we need to do is we need to figure out a function that represents the rate of change in the gallons per, or the gallons of gas per hour. So we want gallons per hour, and sometimes it's helpful to think about it in terms of the units. We want gallons per hour. So if we have, how would we get gallons per hour with miles per gallon and miles per hour? We need to get the miles to cancel out and have the gallons in the numerator, right? So if we had miles per hour divided by miles per gallon, then we should be able to divide those two fractions, right? And make that miles per hour times gallons per mile, which should cancel out the miles and give us gallons per hour. Does that make sense to everybody? So, so we want to take our miles per hour, our 80 times t plus 1 over t plus 2, and divide that by our 4 plus 0.01 v. And then in order to put this all into terms of time, we need to convert the v that's in that denominator there into terms of t. So v is 80 times t plus 1 over t plus 2. So we'll end up with 80 times t plus 1 over t plus 2 over 4 plus 0.01 times 80 times t plus 1 over t plus 2. And then we'll want to integrate that from 0 to 2. And if it were me, I would use a calculator to do that, because this section said use a calculator when necessary. So I'd use a calculator for it. I don't know what it comes out to be. I'm sure it comes out to be something exciting. I don't know. It looks like it comes out to be 23.1 gallons. Make sense? Yeah. And you definitely, I mean, you wouldn't have to integrate that on your own without a calculator on the basis. So everybody go with that one? 31? Cool. That's the last one in that section. That's a short section. Number 15, please. Sure. All right, number 15. What a great problem. It's almost summertime, and it's a problem about the beach. How wonderful. All right, the beach opens at 8 a.m. Beach is always open. People arrive at a rate equal to 10 plus 40 t people per hour. And let's see. No one leaves before noon. We want to know at what time will there be 100 people there. So we are, let's see, what is it? T represents the number of hours the beach has been open. So T equals 0 represents 8 a.m. And so we want to integrate from 0 to some x value. That's the value we're looking for. 10 plus 40t dt. And we want that to equal 100, right? Because if the rate is 10 plus 40t, the integral of that will be the number of people that have arrived. And so we'll figure out how many hours after the beach opens, we'll find x, or when this number of people is 100, right? When 100 people will be there. Does that make sense conceptually on your setup there?
Yes.
Yeah. So then we just end up with 10. We'll have 10t plus 20t squared evaluated from 0 to x equals 100. And we'll have 10x plus 20x squared minus 0 equals 100. And then you'll solve that quadratic for x. So we'll 10x squared plus x minus 10. And I don't know, I mean, they've given you these times. You'll just have to solve that for x and see what? Oh, 10x. Yeah, I said 10x or 2x squared. Yeah. I can divide. So I don't know, use the quadratic formula or whatever to figure out what that comes out to be, and then you'll add that to 8 o'clock based on whatever. This is hours, so you'll have to convert to minutes to figure out the time. What did that come out to be if you? Let's see, it's -1 plus the square root of what? Oh, 81. Yeah. Oh, is that factor? Oh, that factors. I guess we'll just factor it then. I don't know. It didn't look like it would factor, so I didn't even think about it. 2 and a 5 and a plus and a minus. It looks like x equals 2. So 2 hours later after it opens at 8, so it looks like that'd be 10 o'clock. Good? Who else? Nick, you good with that one?
Yes, I am. Thank you.
What?
Yes.
Yes. Okay.
Thank you.
Sure. Other question? Questions in general? I could take questions in general. What questions in general do you have? Sure. Yeah, we can do a couple of those. That's fine. We're looking at, doesn't seem like anybody else had any more from that. So we'll stop on that. You're talking about like the full length practice test that up in Google Drive? Yeah. Sure. I'm happy. If anybody has any questions from any of those, I'm happy to go over those now too. I'll also have time for that during the review session. I mean, a lot of what the review session will be me just kind of answering questions that people have in general. And then once that's done with, I'll go over some free response questions. A lot of them are ones that are posted up in the on the My AP Classroom thing. Like all those things should be open for you to look at, all those free response. So I can go over any of those. There's also multiple choice in there, so I can go over those too during the review session. Anyway, which practice test are we looking at here? 2013. Okay. Sorry, what number? 77. Okay, so this is the 2013 practice test that is up in Google Classroom, number 77, you said? Okay, and that's in the calculator multiple choice, right? Okay. Like this. There we go. I gotta find it. 77. There we go. Okay. The one about the volume of a sphere. All right, we got the volume of the sphere. So hopefully you all can pull that up and look at it at home or here if you want on your phone or your laptop or whatever. we got the volume of a sphere, and it is decreasing at a constant rate of 3 centimeters cubed per second. And we are interested when at the instant when the radius is decreasing at a rate of 0.25 centimeters per second, we want to know what is R. That's an R, not a V. Yeah, and then they give us a formula for the volume of the sphere, which they often like to do on the AP test, is to give you formulas. It never anywhere guarantees that they will, but generally they'll give you, unless it's like a rectangular box, or like the area of a circle, or area of a triangle. Basic area formulas they won't normally give you, but usually they give you volume or surface area. All right, so this is a related rate problem. So we're just going to take the derivative of both sides of it with respect to t. So we'll get dv dt equals 4/3 times 3 pi r squared dr dt, and then the 3's will cancel there. So really we're just left with 4 pi r squared dr dt. Good with that so far? And then we've got the volume of the sphere is decreasing at 3 centimeters per second. So that's our dv dt. And this is since it's decreasing, we'll make that a negative value, -3. And then we've got pi, we've got our radius squared, which is what we're looking for. We're looking for the value of the radius. And then our dr dt is this -0.25 or -1/4. And so it looks like we end up with r squared equals, if we multiply the -4 over, that's a 12, divided by the pi, we get r squared equals 12 over pi, or r equals whatever the square root of 12 over pi is, which, I don't know, I don't have the answer in front of me, but one of those things must be the square root of 12 over pi. E is the square root of 12 over pi. That make sense? Cool. Other questions that people have in general? Chat. What did I do with the 4? This 4 here? Is that what you're talking about? The 4 in front of the pi. Oh, did I get rid of the 4 in front of the pi? Oh, I did. I got rid of the 4 in front of the pi. Oh, I got rid of the 4 in front of the pi. Never mind, that shouldn't be 12 over pi. That's my fault. Thank you. I got rid of the 4. Those should cancel out, and we end up with 3 over pi. Sorry. Was it still E? It's still E? Okay. 0.977. Yeah, that should be 3 over pi. Yeah, thank you. I don't know. I don't know what I did with that 4. I had it there, and then it disappeared. Don't let things disappear like that on a test, because then you get it wrong. That was bad. All right. Other questions? 78 from the same one. Let's see, we got so small on my phone. We've got an integral from 0 to 10 of f of x is 21. We've got an integral from 0 to 10 of 1/2 of g of x, which is 8. We've got an integral from 3 to 10 of f of x minus g of x is 2. And we want to know the integral from 0 to 3 of f of x minus g of x. So, yeah. Oh, yeah, I read it. Did I say 10? I said 10. I wrote a 12. I think I got brain damage or something. I don't know. All right. So they're giving us stuff from 0 to 10. They're giving us stuff from 3 to 10. They're asking about 0 to 3. So we should recognize that the integral from 0 to 3 of f minus g ought to equal the integral from 0 to 10 of f minus g minus the integral from 3 to 10 of f minus g, right? Does that make sense to everybody? Right, if I take the area underneath f minus g from 0 to 10 and then get rid of the part from 3 to 10, that should be just the part from 0 to 3. So what we need to do then is figure out what all of these other things are. So we're given this first one, but we're not given this second one. So if we could separate this out, this one should be the integral from 0 to 10 of f minus the integral from 0 to 10 of g. And then we'll have a minus 2 here at the end, right? Because this one's just 2. So then we've already got the 0 to 10 of f, right? That's 21. So 21 minus something minus 2. And so then we got to figure out what the integral from 0 to 10 of g of x is. Well, we are given the integral from 0 to 10 of half of g of x. That half can come out, right? That half can be pulled out. So 1/2 the integral from 0 to 10 of g of x is 8. So what is the integral from 0 to 10 then? Just multiply by 2. So the integral from 0 to 10 of g of x ought to be 16. Does that make sense? So then we'll just throw our 16 in there. And we end up with 3. Choice A. Exciting. Other questions? I think the quiz tomorrow will just be one question. We'll just do one question tomorrow. And then we'll spend the rest of the time going through some more stuff. Yeah, that sounds like a good plan.
Is that because you think your son's going to be do bad, or?
No, that's because I want to successfully prepare you and use as much of the class time as I can to prepare you for the AP test. Because I'm a good educator.
Perfect. Are we thinking a calculator or a non-calculator?
Yep.
Okay.
I don't know. What do you prefer?
I don't know.
Anybody have a preference? Calculator versus non-calculator?
Calculator.
One preference for calculator. 2 for calculator.
Calculators.
Okay. All right, sure. One calculator problem. Sounds like fun. Other questions? No? That's it? Everybody's good? All right. In that case, I say we go through some more of those miscellaneous FRQs. I think was there one that we were supposed to go through that we had already, was it the grass one? With the decomposing grass clippings? All right, let me get that open here. Wow, people didn't have as many questions today. All right, number 7, grass clippings. Yes, okay. Wonderful. How'd you guys do with this one? Good, bad? Got up to C. Okay. That's better than not getting up to C. All right, so for part A, we want to find the average rate. I have to show this problem.
We're still looking at
Yeah, I gotcha. Now you can see it?
Yes.
Wonderful. All right. For part A, we're going to find the average rate of change of A of t over the interval. What is average rate of change? Average rate of change is just a slope between 2 points. So we're looking for the average rate of change of A on the interval 0 to 30. So that's A of 30 minus A of 0 over 30 minus 0. This being a calculator problem, you can just plug in 30 into your calculator for this and 0 and see what you get. Subtract them and divide it by 30. Looks like it came out to be negative 0.197. Indicate units of measure. So this is pounds divided by days, pounds per day. Everybody good with part A? Hopefully that part was pretty easy. 1 point for answer with units. Answer without units, 0 points. Units without answer, 0 points. 1 point for answer with units. Sometimes it's 1 point for the answer and 1 point for the units. So like, even if you have no idea what to do, at least if you know what the right units are, put the right units because there's a chance you might get a point for it. But you never know. All right, part B, find the value of A prime of 15. So, well, your calculator will tell you what the value of A prime of 15 is. Please don't waste your time trying to take the derivative of this by hand. Just have your calculator tell you what the derivative of that is at 15, right? A prime of 15 is approximately equal to, and then you'll say negative 0.164. Yeah? And then says, using correct units, interpret the meaning of this. Well, this is the derivative of the amount of grass clippings. And so that's a negative, which will tell us that what? At t equals 15, the amount of grass clippings is decreasing at 0.164 pounds per day. And there's your units, pounds per day. And that was worth 2 points. 1 point for the number, 1 point for the explanation. How do we feel about that? Feel okay about that? Okay. Part C. Part C said something about find the time at which the average number of grass clippings is equal to the number of grass clippings or something like that. Okay. So it sounds complicated. Yeah, figure out when the number of grass clippings is the same as the average number of grass clippings. Well, I mean, all that is the amount, the amount of grass needs to equal the average amount of grass. So just write an equation. What is the amount of grass clippings in the bin? What is the function that represents the amount of grass clippings in the bin?
A of t.
No, the amount of grass in the bin is just A of t. Isn't that what it says? Grass clippings are placed in a bin where they decompose. For 0 to 30, the amount of grass clippings remaining in the bin is this. Number of grass clippings in the bin is A of t. That's all it is. And that's the amount in the bin. What is the average amount of grass clippings in the bin? That, what is it? Did they give us a time period? 0 to 30, right? That is the average value of the function that represents the number of grass clippings in the bin. So that's the integral from 0 to 30 of A of t dt. So we want to know when are these two things equal to each other, right? So you've got a calculator, right? You can evaluate the average amount of grass clippings in the bin. That came out to be, I don't know, the scoring guidelines don't tell me. Anybody get a value for 1/30th of the integral from 0 to 30 of A?
I got like 2.753.
2.753. Perfect. Okay. I don't know if that's right, but we'll assume it is. And then when you set A of t equal to that and graph both this and y equals this, and look for the point of intersection, what was your point of intersection? Should have been t equals 12.415. Alternatively, you can take A of t and subtract 2.753 from it, and then just graph that single function and see where it has an x-intercept.
So how do you calculate that on the graph was my question though. Because whenever you like press the calc button on your graph, it just gives you x equals, not y equals.
What? I'm not sure what your question is. What do you mean it gives you x equals, not y equals?
Like, how would you put this into your calculator to solve?
All right. I would go into my graphs and I would graph A of t. So I would graph 6.687 times, I don't know, whatever it is, the t, 0.931 for the t. And I would also graph y equals 2.753, and I would just look for the point of intersection of those two functions.
Okay, thank you. Just
Or,
okay.
or I would graph this 6.687 times 0.931 to the t minus 2.753, and then look for the x-intercept of that. So this would either be the intersection of these or the x-intercept of this. Does that make sense?
Yes, thank you.
Sure. That was worth 2 points. 1 point if you use the average value theorem, the mean value theorem for integrals. 1 point for getting the answer. All right, part D. It says for t greater than 30, the linear approximation of A at 30 is a better model for the amount of grass clippings. Use L of t to predict the time in which there will be a half a pound of grass clippings. So what is the linearization formula? The linearization formula, if we remember, just in general, linearization of some function at x is equal to the function at a plus f prime of a times x minus a. That's our linearization, right? Everybody remember that? That's just from like the tangent line equation, hopefully. A is the value we know. So in our case, A is going to be 30 because it says we're using the linear approximation at 30. And we're looking for the time, t, at which this is equal to a half. So we've got, instead of f of a, we're going to have capital A at a. And we're going to, instead of having x, we're going to have t. So we should have capital A of 30 plus a prime of 30 times t minus 30. And what do we want that to equal? 1/2. And so then we will just use our calculator to solve this. We can find the value of A of 30. In fact, we already, I think, found it in part A, I believe. I don't know what it was offhand. It looks like it was 0.782928. And then A prime of 30, which we also found. No, we didn't find before, but now we can find it, is negative 0.055976. So just take your 1/2, subtract the 0.782 thing, divide by negative 0.055, add 30, and you end up with t equals 35.054. Does that make sense to everybody? All good? That one is worth 4 points. 1 for this expression for L of t, 1 for setting L of, no, sorry, 2 for this, 1 for setting that L of t equal to a half, and then 1 for the answer. Good or no? I had some grass clippings decomposing in a trash can in front of my house. So yesterday. And then they came and took the trash. They're no longer decomposing there. They're decomposing elsewhere. Very exciting. How do we feel about that one? Good or no? Feel okay about it now? Let's see. We want a calculator one, right? You guys want to practice a calculator one? Since I said we'll do a calculator one on the quiz tomorrow, that seems reasonable. How about this one? This is a good one. Water in a tub? Or we want to have a pot of tea cooling? I do like tea. Or are we having a tub of water? Preference? Nope. All right, this is the one it is, then I don't have to click it again. All right, I'll give you guys about 15 minutes to work through it, see how you can do, and then we'll go through it. Good? Good. Ready? Begin. Part A, we want to approximate or estimate W prime of 12. So if we're approximating W prime of 12, that means we're just going to find the average rate of change on the interval surrounding 12. So we'll do 67.9 minus 61.8 over 15 minus 9, because that's the smallest interval around 12 that we can get. And what did that come out to be? 1.017? Question? Yeah, that'd be fine. Usually they're, pretty much always they have it as an equal amount on either side of it. I don't think I've ever seen it where it's not. Sometimes they might ask you to approximate it at like 0 or at 20, in which case you'd use, whatever that endpoint is, and then the next closest thing you have. But usually it's, like I said, I've never seen one where they weren't the same distance apart that I can think of offhand. So that came out to 1.017. Is that what you guys got? Yeah. And then let's see, interpret the meaning of this. Well, this is the derivative of the, what are we? This is the derivative of the temperature, right? So that should be the temperature is increasing at 1.017 degrees Fahrenheit per minute at 12 minutes. Good. That's the instantaneous rate of change of the temperature, or at least an approximation for it at t equals 12. Everybody good with part A? 2 points, 1 for the number, 1 for the explanation with units. All right. Part B, use the data in the table to evaluate the integral from 0 to 20 of W prime. Well, what's the integral of W prime? That's just W, isn't it? So we'll evaluate W from 0 to 20, which ought to be 71 minus 55, which is 16. And using correct units, interpret the meaning of that. So that should be, what would that be? That is just the change in degrees Fahrenheit from t equals 0 to t equals 20. Yeah? Good or not? And that was worth 2 points, 1 for the value and 1 for the interpretation. Everybody good there with A and B? For part C, we want, for part C, we want to look at this 1/20th of the integral from 0 to 20. We're going to use a left Riemann sum to approximate that. And then we're going to sort of talk about it. Right? So that's the average temperature of the water, right? The integral from 0 to 20 times 1 over 20 minus 0 of the water temperature function. So using a left Riemann sum, the first value should be 55, and we should multiply it by the length of that first interval, which is 4. Then it should be 57.1, and that should be multiplied by 5. And then it should be 61.8, and that should be multiplied by 6. And then it should be 67.9, and that should be multiplied by 5. And what did that come out to be? And we need to divide it by 20, right? What did that come out to be? $60.79. Sounds good to me. Okay. And is this an over or an underestimate of the average temperature? Well, the integral itself should be what? The function is increasing, so a left Riemann sum should underestimate, right? So this should be underestimate. And you would give a reason as the function is increasing. And you'd write it out a little nicer than underestimate, comma, WINC. But tells us up here it's strictly increasing function, which tells us the left Riemann sum will underestimate. Everybody good with part C? And that was worth 3 points, 1 for the correct setup with the Riemann sum, 1 for the value, and 1 for underestimate because it's increasing. Cool. And then part D. So D says for 20 to 25, W models the water temperature, has this derivative. We want to know what is the water temperature at 25. So how do we figure out the water temperature at 25? We just need to take the integral of that derivative from 20 to 25, and then what do we need to do with that? Add our 71 to it, right? The temperature at 20. So it'll be 71, this would be 71 plus the integral from 20 to 25 of W prime of T dt. And looks like that came out to be 73.043. And that was worth 2 points, 1 for having this integral set up correctly and 1 for the final value. How many of you got all 9 points? Bad. How many of you got more than 7? B? B was 2 points, 1 for the value and 1 for the explanation. 7 out of 9 is good. If you can get 7 out of 9 on every free response, you're in good shape. Last one was just 2 points. 1 for having the integral as part of it somewhere, and then 1 for the final value. Yeah. 7 out of 9, if you're getting 7 out of 9, like I said, that is good. 7 out of 9 puts you fairly solidly in the range of getting a 5. Like I would say, if you get 7 out of 9 on all of them, and you know, probably get 2/3 of the multiple choice right, you're pretty set on a 5. And that's what we all want, right? Yeah. All right. Should we do? And we don't have time to do another one. Probably shouldn't do another one. We're gonna have a quiz tomorrow. I don't know. Like I said, we'll do a calculator one. Maybe do this one about the teapot tonight. Might be good practice. If you have questions on it, just send me a remind message. Right, there's another calculator one. Or maybe this one about the zoo and the baby elephants. You probably won't do that. Yeah. Yeah, if you're looking for a couple to do tonight, I would say do number whatever this is with the teapot and the baby elephants at the zoo. Those would be good practice for what we'll see tomorrow. Other than that, I think that's good for today.